Yeah, at academia is cool, man, but I'd like to kind of get a more stylized, something that is more realistic. Yeah, like something from National Geographic. These guys, they actually dig a hole to the center of the earth. Yeah, man, they really did it. Let's check it out.
It was a secret government program known as Project Destiny.
We're building a weapon that could generate targeted seismic events.
Designed to use earthquakes to attack our enemies.
I'm getting a seismic reading.
It was a perfect, untraceable weapon.
Destiny is a go.
Until something went wrong.
That's an electrical superstorm.
Popping up all over the world.
I'll put this as simply as I can. Everybody on Earth is dead in a year.
The core of the Earth has stopped spinning.
The spinning core protects us from cosmic radiation.
Without it, radiation will create superstorms. Microwaves will literally cook our planet.
How could this have happened?
It was Project Destiny. We killed the planet.
So, how do we fix it?
We can't. The core is the size of Mars. You're talking about jump-starting a planet.
What if we could?
We're here about your legendary ship.
What would it take to get it in 3 months?
$50 billion.
You take a check?
We need you to control the flow of information.
You want me to hack the planet? I'm gonna need Star Trek tapes and Hot Pockets.
You are good. Is there anything you can't do?
Not that I'm aware of.
You're trying to save the world. It's impossible. I came here to save my wife and children. I just hope I'm brave enough to save 3.
I can't wait to get into an untested ship, go to the center of the Earth, and restart its core with 1,000 megatons of nuclear weapons. Then we outrun the biggest shockwave in history.
Hot damn.
San Francisco is in ruins.
The whole West Coast is out. And it's decaying faster than we thought.
2, 1.
We're going in.
Whoever goes into the core is not coming back.
We're losing oxygen!
Reach!
We got a job to do. Let's do it.
Yeah, right. The Earth's core. No. But we do have we can take a look here at this, the National Geographic rendition. We're going to start at the surface, actually start from the atmosphere, and then penetrate into the Earth's core, just to kind of get an idea of, well, what's down there. So let's take a look here now. The National Geographic. I'm not going to watch the whole thing. You can on your own if you
It's
like.
not in space, not on Earth, but deep inside. We think we walk on solid ground. But dare to travel inside our planet and we'll discover another world. Filled with bizarre creatures that live only underground. We'll see gold form before our eyes. Feel 1200 degree heat inside a volcano. Discover diamonds buried 240 kilometers down.
We're not going to watch the
And
whole thing. We're
giant
just gonna
tornadoes of
take a
liquid
look.
iron. Until over 6,000...
And here's the good stuff right here. The vorticular aspect.
We think we walk on solid ground. But dare to travel inside our planet and we'll discover another world. Filled with bizarre creatures that live only underground. We'll see gold form before our eyes. Feel 1200 degree heat inside a volcano. Discover diamonds buried 240 kilometers down. And giant tornadoes of liquid...
Giant tornadoes.
Liquid iron.
Liquid iron.
Until over
Area.
6,000 kilometers down at the center of the Earth, we reach its beating heart. Our planet can destroy us. Immense forces trapped beneath the surface could explode at any time and unleash hell. Beneath our feet lies our greatest enemy. It is also our greatest ally. We built civilization with material from inside the Earth. Its story is our story. This coal mine in the American heartland is our entry. "15 meters. 45 meters. 70 meters below the Illinois cornfields. Light, life, everything that's familiar, safe, lies behind us. Ahead, darkness, danger, the unknown. This is no ordinary coal mine. Fossilized leaves and plants cover the ceiling. This was once a living forest. Now it's solid rock buried inside the earth.
So here we are in the crust, huh? Let's take her down a little bit further here. You can see here the rendition of how they dig.
Now we know. All this is made of long-dead sea creatures. Crushed, dissolved and mobilized to form giant columns. Created as a stalactite from the ceiling, met a stalagmite from the ground. And fragile soda straw stalactites. It can take 100 years or more to grow just 2.5 centimeters of these hollow calcite tubes.
In Virginia, they've experienced some of these stalactites and formations developing in 20 years or less.
Maximum bone-crushing action.
Hey, it's Uncle Dinosaur.
No predators. Nothing could unseat this lizard king. But 2,400 kilometers to the south, a storm was brewing. The asteroid struck off Mexico's Yucatan coast. And released the energy of 100 million atomic bombs. At the point of impact, temperatures reached 20,000 degrees Celsius. Hot enough to vaporize the Earth's crust. Every living thing within a 500-kilometer radius. And the asteroid itself.
The ultimate toroidal ring, the compression associated with that, We're going to look at that later in the course also. Toroidal energy.
The impact smashed them all into a towering dust cloud. The cloud couldn't escape the Earth's gravity. It smothered the entire planet. A local disaster became a global catastrophe. Across North America, day turned to night. For months. With no sunlight, plants perished. The plant eaters starved. The meat eaters died. The dinosaurs, arguably the planet's biggest, most successful species ever, were finished. This thin layer of rock, 550 meters deep, is a prehistoric killer. 65 million years ago, it killed the dinosaurs and wiped out 75% of all life.
See, what they're talking about here is the iridium layer that manifests itself in a large portion of the Earth's crust.
This is more than a mission to the core. It's a journey through the Earth's past.
So you see the little counter over here, we're at 564.8 meters.
A band of red rocks. They're full of rust. How did millions of tons of rust wind up 600 meters beneath Michigan? 3.5 billion years ago, there was a shallow sea here. Home to one of the Earth's earliest life forms. Colonies of living bacteria called stromatolites. As if by magic, these bacteria turn sunlight into food. And in the process, they released a gas. Oxygen. Oxygen transformed life on Earth. It made the atmosphere breathable. And turned traces of iron dissolved in the oceans to rust. This fell to the ocean floor to form layers of iron-rich rock. Today, we mine these rocks, extract the iron, and use it to build cars, planes, bridges, skyscrapers.
Oxidation, huh? Let's go a little deeper here.
Visited the deepest ocean, but no human has ventured beyond this point.
So the Marianas Trench, the deepest point known to man on the Earth, but now we're going beyond that as far as depth goes. You saw the counter right here. take a look at
made
it.
of quartz.
Amethyst.
Iron impurities made this quartz purple. It's an amethyst.
Just point of interest, the tetrahedral aspect of the crystalline structure there is interesting. Whereas most of nanotechnology is based in six-sided figures or hexagonal.
Sapphires. Rubies.
Notice here the arcoidal or the random structure in the sapphires also. There was a more random.
Emeralds. It takes millions of years of wind, rain, and tectonic plates movements to bring them near the surface. But for every gem we find, there must be tons buried, never to be seen. We're nearly 4 kilometers down. Mankind has looked into distant space, visited the deepest ocean, but no human has ventured beyond this point. It's time to enter the unknown. We're deeper than any human has ever traveled. 4 kilometers inside the Earth's crust, beneath the floor of the Gulf of Mexico. Around us, a layer of rock hundreds of kilometers wide, over 1.5 kilometers thick. It's salt. Trillions of tons of salt. We use it to grit our roads, flavor our food. In fact, without salt...
So notice the rhombic or the square matrix here.
We'd die.
Cubic.
But how did trillions of tons of salt wind up here, beneath the ocean? $160 million years ago, a vast scorched basin stretched between Texas and the Yucatan. Like Death Valley, it was below sea level and hot. Briny springs bubbled up through the bottom of the basin. In the intense heat, the water evaporated quickly to leave a thin salt crust. Over 2 million years, the salt grew thicker. Until we're back where we started, inside a layer of salt that's over 1.5 kilometers thick, buried 4 kilometers beneath the floor of the Gulf of Mexico. Sealed below the salt, 5.5 kilometers down, a layer of porous sandstone full of a thick, black liquid.
What do you suppose that is? Yeah, petroleum. Huh?
We've struck oil.
Old dinosaurs, rotten dinosaurs. Let's go on down here. We don't want to waste too much time up here in the crust. Gotta get into the mantle.
moving west at about 10 centimeters a year.
Suboceanic tectonics.
At this speed, it'll take 170 million years to follow the crust across the Pacific. Time to hit fast forward.
Let's imagine the Pacific Ring of Fire and the
We're riding the Pacific Ocean plate away from America towards Asia. The crust is sliding down into some kind of chasm. This has to be the legendary Mariana Trench, the deepest point on the Earth's surface. We're at the trench's rim, 5 kilometers beneath the ocean's surface, far below the reach of the sun's rays. An anglerfish. Like a firefly, it's generating its own light, switching it on and off to lure in its prey.
bioluminescence.
Six and a half kilometers down, deeper into the abyss. Eight kilometers down, we finally reach the ocean floor. But one section of the trench descends even further. "11 kilometers below sea level, this is the lowest point on the planet's surface. The Challenger Deep. Deeper than Everest is tall. Pressure is over 1,000 times greater than at sea level. It would squeeze every last square centimeter of air from our bodies until we were compacted like a crushed car.
Roughly 14,800.
The trench is where the Pacific Plate meets another of the great plates that make up the Earth's crust, the Philippine Plate. The Pacific Plate is saturated with water. Its rock compacted over millions of years beneath the weight of the ocean. It's so dense, at high speed we can see it plunging beneath the lighter Philippine Plate. This is where the old crust goes. Here, 11 kilometers under the Pacific Ocean, the Earth swallows the old crust. Our planet is literally eating itself.
Or circulating in a convective fashion, so that the surface plate diving underneath the continental plate here, Philippine, then this is replenishing the Earth's core, and we're going to see how that works here. Vigorous mantle, excuse me. The core is pretty much down here. It's the engine.
We're back inside. Make the surrounding rock transparent, and we can see there's molten rock all around us, rising up towards the surface. Molten rock is less dense than solid rock, so like heat, it rises.
Lava lamp, huh? Yeah.
And keeps rising. This is as close as it gets. We're inside a vast chamber full of billions of liters of molten hot rock. The pressure is overwhelming. It forces gases and water out of the magma up at high speed, until they punch through the crust to erupt as a volcano. A terrible, beautiful monument to the immense power locked within. Power that can melt solid rock, heating it to over 1,000 degrees Celsius. Blast bombs of lava as big as buses thousands of feet into the sky. And send a wall of 800-degree ash and rock down the volcano at 240 kilometers an hour. Get in its way, and the ash would fill our lungs, burn, and suffocate us. Grit and hot toxic gases would sandblast our skin. The world beneath the surface has the power to blast millions of tons of gas and pulverized rock high into the atmosphere, creating acid rain, blocking out the sun for months, even years on end. And this is just one volcano. There are 600 or more round the Earth that are still active. 3/4 of them sit in a ring of fire around the Pacific Ocean. These volcanoes trace the line right where the Pacific Ocean plate sinks below the continental plate. From here, we can see how it's all connected. The plates, the San Andreas Fault, the mid-ocean ridge, earthquakes, volcanoes. They're all part of the cycle of destruction and renewal that makes our planet dynamic. But there's one cluster of volcanoes that doesn't fit in. Thousands of kilometers from the Ring of Fire, in the middle of the Pacific Ocean, is the volcanic island chain of Hawaii. Hawaii sits in the center of the oceanic plate, far from any crack in the Earth's crust. These islands shouldn't exist. This is the Big Island, home to Hawaii's most active volcano, Kilauea. The volcano erupts along a series of rifts, spewing out up to 500,000 cubic meters of lava every day, enough to resurface a 30-kilometer highway.
So we're going to see here how there's another plume further off to the east of Kilauea, forming a new island out there. But we need to get down into the
Way
mantle,
down here.
down into towards the core of the Earth.
Kilometer of hot green rock. But make the mantle rock transparent, and we can see there's something different down here. A slab of rock that must be hundreds of kilometers wide. Infrared reveals the slab is much cooler than the surrounding mantle rock. The slab is cooler because the rock is saturated with water.
Seawater in the mantle, so it's like the tectonic, the surface plates actually absorb the water and then carry it down in, which provides the energy for the reactions.
The stranger things get. "500 kilometers inside the Earth. The massive slab of rock is saturated with seawater. There's only one possible explanation. This is one of the plates that make up the Earth's crust. As one plate sank beneath another plate, it carried seawater down toward the core. This is part of the Earth's ancient crust. There are other slabs down here too, intruders from another geologic era. One day, millions of years from now, the crust we live on may end up down here. Our world on the surface that feels so solid, so permanent, is anything but. 660 kilometers down, the slabs are piling up. It's an avalanche inside the Earth on an epic scale. Over tens of millions of years, trillions of tons of rock plunge into the mantle's mysterious depths. The colder material sinks and pushes up rock heated by the core.
So there's the convective gradient we're talking about, or circulative patterns, so that cold falls, heat rises, the core is the source of the heat. I'm pretty sure we're going to find out that it's isotopic degradation that drives the core also, so it's like an atomic reactor down there.
Speed up time, and we can see the rock rising up like hot wax in a lava lamp. It's forcing its way through solid mantle rock, getting softer and more liquid as it rises.
And that's due to the physics. As the pressure decreases, it allows it to become more viscous and expand. So it would also cool, but it's pretty hot to begin with. So
on and up, a vast column of hot rock, at least 1,000 kilometers wide, 600 kilometers tall. The column is big enough and hot enough to burn through the crust, to create a volcano far from a plate boundary. This is how we got Hawaii. The volcanic island chain is at the top of a giant column of hot rock that stretches hundreds of kilometers down into the mantle. But we need to travel down, not up, towards the core, not the crust. We've no choice but to dive back in, down through nearly 1,500 degree rock.
So you see the 1,500 degree temperatures in the mantle?
200 kilometers. 600 kilometers. 1,000 kilometers. 1,500 kilometers inside the Earth. We're over halfway to the core now. We've traveled through the Earth's crust, into the mantle's deepest depths. The rock is softer, tackier. We're getting hotter. 2,000 kilometers down. 2,300 kilometers. We're getting closer. Closer to the heart of our planet. 3,000 kilometers down. This is it. The force that carves up continents, powers volcanoes and earthquakes. The pivot around which the Earth spins. The center of the labyrinth. It's time to enter the core. The core. We've arrived. This is the Earth's core. It's molten iron and nickel. So hot, it glows yellow. And it's bigger than the moon. Everything that exists on Earth exists because of this. The heat that creates earthquakes and volcanoes, that keeps the continents moving and our planet active, comes from inside this. It looks like it's snowing. Up. As pressure drops between the core and the mantle, impurities rain out of the core's liquid metal, like bubbles escaping from an open soda bottle. The cooling crystallized minerals settle as dunes on the underside of the mantle. We've only just reached its outer edge. But already the core is more complex, more beautiful.
Here you see, start to see the manifestation of the plasma element. They're trying to show you here with the lightning.
Beautiful. And more dangerous than we'd ever imagined. towering tornadoes of liquid metal. There are dozens of them. Each one is thousands of kilometers high, tens of kilometers wide. The currents are spiraling up towards the core's outer edge and sinking back towards the center at a speed of about 10 kilometers a year.
When you take that to scale, though, that's moving pretty fast for the size of these things. And you see the vorticular manifestation, or he's calling it a tornado.
Slow by our standards. Supersonic in geological terms. Speed up time by a factor of 50,000, and things get scary. It's 4,000 degrees down here. Such heat creates these columns of hot metal. Then the Earth's rotation twists the columns into giant tornadoes. Together, the spiraling columns turn the core into a giant electromagnet. It's so colossal the force field it generates extends far beyond the core, through the mantle, the crust, out into space.
The essence
to
of
create a magnetic
here.
shield around our planet. Protecting the Earth from the deadly solar wind. Without these electromagnetic tornadoes, the Earth's surface would be a lifeless desert.
But
nothing at all
here's
exists.
The generating force in the core of the Earth itself.
This is truly the perfect storm. A chance combination of motion and heat that keeps our world safe. Every wonder we've seen, every terror, the core's heat drives them all.
The essence of geothermal energy here.
We can see the heat, feel it, but we still don't know why the core is so hot. What creates all this heat? The answer lies back in time, long before the Earth was born. 4.5 billion years ago. Rocks circled the infant sun. As they collided, they released energy as heat. Most of this heat radiated out into space. But a small fraction stayed inside the growing ball of rock.
Oh, iridium.
The ball became a planet. And as gravity increased, it pulled the densest elements towards the planet's center. These elements sank, creating friction and heat. And as unstable radioactive elements like uranium, potassium, and thorium broke down, they released even more heat.
Reactor, so to speak.
4.5 billion years later, wrapped within layers of rock, insulated beneath a blanket of crust, the core is still hot. This heat is the core's greatest gift to us. Everything that makes our world so beautiful, so volatile, owes its existence to this ancient energy source. But our journey isn't over. Right now it's time to enter the planet's inner sanctum, to tunnel through solid iron into the inner core. The pressure is so intense, it would crush us down and squeeze every element out of our bodies until all that remains is carbon, compacted to a single diamond. After a 6,400 kilometer journey, we reach the absolute center of the Earth. Two forces have dominated our journey: heat and pressure. This is their zenith, their ground zero. It's the planet's hottest place, hotter even than the surface of the sun. Pressure is 3.5 million times stronger than where we live on the surface. We don't know precisely what the inner core is made of, how fast it's growing, when it first appeared, what role it plays. It's a scientific black hole at the heart of our planet. This is where science ends and speculation begins. But from the unknowable, impossible core come the things that make our world possible. Magnetism that protects our world from the sun's deadly rays and allows life to flourish.
We're out of here. I thought we had it till 5.
Currents that drive the plates around the Earth. Precious gems.
This is geothermal energy.
Their beauty captivates us. Their properties help power our technology. Gold